Second, guys, yes. This is just in this, okay. So I got two videos recording. Okay. Okay. What you are recording this video now, what you should basically know will working. So that is what you are. So let's try to code it twice. Okay. So today's video is on the Sonar system, Sonar radio system system for people outside the constitution via command and control sequences, command and control sequences, command and control sequences of instruction sets. So what am I talking about here? So basically, basically, guys, if you look carefully here, I don't know what's here. So look carefully here. No, I am let's just go in the system here. So this is Sonar by Ocean Services knock NO Sonar. So I'm going to give you so you got the formulation of the because I can't see the camera here. I'm putting two things at once right now. You got the formalization of the system here for it, but it should to work it. We should to do so 1 3 1 A 1 B 1 3 1 C E. So we really okay, basically we really don't got this one. But this was no I feel like it's unorthodox. So, it's no basically it's obedience essay or king, tier. But I haven't got the thing here. I haven't got my sheet of paper here. It's probably my bag or something. No. Okay. I've been going through it a bit. I'm going to tidying up, but that's how it goes. When you are scattered, your thoughts in your mind, but you have when it's gonna tidy, untidy, but it's not mindful. I just go that, shouldn't do it. But so where was I? So okay, so the control and command sequences of the system for the sonar is basically what I'm talking about here. But this sonar uses so you get the radio waves, use radio for the surface and you get the depth of the ocean. But it's an ocean system, so because we have a border, we have a bright to Biafra, bright to Benin, and bright to Biafra. I'm a low switch is very good at making me do this properly. But I'm not scared of anyone. Don't try put on three one. So I am not, I'm still here. But this is solar system. But this solar system, we're gonna watch this video and see what I mean. But the formulation is already here, so we're gonna watch this video first. Okay, so let's go watch the video. So it's solar sound. I'm saying, what's talking? I'm saying, I'm saying. Can you see this comply? It's kind of properly hard to say. This is sonar, but sonar is a sound system. It is no. You got lidar, which is a light system. You got sonar, which is a sound system, and you got radio, which is a radio system. But all this can be mapped to radio, so that's why we do this. So it's not destroying problems. It's just the same problem, but a different content. It's just radio with you. You should know read the channel on the water. I'll be surprised, because I want to do, I want to have proper radio on the water that doesn't disconnect, because the disconnect is mostly underwater. But I've got this kind of command and control system, which I'm trying to execute today, because I can do so. This is a big issue. But this video I'm watching is this is telling me about Sonar and the NOAC end for November of Oscar if alpha. It's one of the most advanced. So red is for the shallow depth, blue and purple is for the big depths, the deeper depth. I suppose the depth is like 50 kilometers. 50 kilometers, 3,000 meters. But that's what I remember it to be. But I'm thinking about trenches underwater. I'm thinking about because you got 50 meters. 50 meters is a trench. It's a trench footing. But that's the United Nations. So by law, something about the United Nations, 50 meters. So this is a 50 meters trench. 25 to 50 meters, I believe it is. But 25 every 25 minutes there's a trench. Every 50 meters be another trench. So every 50 meters is a trench. You cannot go past. The trench is basically a safety protocol for people who are using the trenches. But it's not really making sense to me. Why? I think it was 15 meters, but because the trenches are 15. No, it's not 25, it's 15. So 15 meters is a trench. So every 15 meters back and forth, every 15 meters, 15, 25, and 50. So it goes up in from 15, 25, from 0 to 50. It was weird to me, but I remember it as that. I can't remember the formal website for it. But I believe 15 meters, 15, 20, 20, 15 meters onwards, you can add more trenches for safety margins. 15 to 50 meters, you can remember. So the kind of thing I'm saying is, can you get an underwater base? Can you get an underwater base? You know what I'm saying? I want another underwater middle base too, because I'm about to prepare for my PhD. I want to see what I can solve when I can attack this kind of collision problem via a control and command system. But this is basically what it is. So you got LiDAR, which is laser. They work on laser sounds, laser, but they work on light. But they produce images in depth of images. But LiDAR is basically the kind of LED that works on electricity. But LiDAR is very good, but Sonar is one of the most. So you guys see the ping and you're gonna sonar bloop. But this is just talking about the ping first. Let's go to the ping before we go to the bloop. Okay. So, like I said, okay. So this is good what you do. This is using the access of the voice down. But this is sonar, it's sound waves. So you're gonna have a radio sound, and that's why I love it. So so two or four things, and that is formally, of course. So you got this a detonator. A detonator is a blasting cap. The blasting cap is a small explosive device or constitute of explosive device which can convert into a fuse. Can convert the fuse. Fuse. So you got a fuse and a detonator. A fuse and detonator. So now we're gonna go with fuse. Fuse. So I'll come on to that. So fuse. A fuse is a device a fuse, a fuse is an electrical safety device that operates to prevent overcurrent protection of an electric circuit. It's essentially a component of a metal wire and a strip of metal. I went too much, kind of long story. When too much goes, therefore stop it and too much it stops kind of with the fuse. So the fuse, so you got like kind of a mechanical fuses, but in kitchens, those are electrical currents. Where they you can when you turn off a cooker, you have a fuse. You can turn off the cooker, you initiate the fuse, but the fuse or the power, it doesn't let the power get through the system of the cooker, and that's what you guys have because in the very important, there's just symbols of a fuse. You're saying. So I love this. I love but the fuse is one of the best things ever. Though because it's a safety measure, but it's not enough. It's not enough. We need more types of fuse. I'm saying to you, The problem with fuses kind of right now is like a, it's kind of like a one size fits all solution. Wow, who put that there? Who made this for fuses? Because they love it so much, they build it around them. But you can't just have one type of. You can't have one kind of confusion. You cannot have this kind of one. You can't. You can't. You got a breaking cap. So the breaking cap, use the voltage. You can't just have one type of voltage in the fuse. You have to have different type. So I'm trying to explain the kind of fuse design you have. Fuse holders. But because it's a safety measure. It's not a requirement. It's a safety measure. It's a requirement that's needed. No, you don't want the requirement. So I have to just try to make more fuse type this kind of electronic devices. But if I can, I can't do it. And then we got a detonator. So a detonator is a blasting cap. So it's supposed to, so you can explode, so you can detonate. So inserting detonator into C4, C4. Yeah, but this is a detonator being inserted because it gives you the kind of use of a detonator, but it's basically gonna carry a current, and that's what I'm saying. The detonator. So I'm gonna say to you guys now, the detonators and the fuse are related in insurance properties. The detonators are related. They're related, and you gotta be sure they're related because if you don't know they're related, you don't know what's happening really here with me. So what I'm gonna say. So I just paper I had. Yeah, and I'm proud of these people. So last time we were talking about how to use an XO encoding to determine Alice and Bob, to override the control of Alice and Bob, Alice and Bob with a hijack sequence via an interception of no of control and command. Basically, you're trying to take over a system via replacing the bits and bytes they have. The sequence which you do right. Why the actual was running. So this like the canonical. You're executing you're executing the canonical code on the fly. So the canonical code is basically what you're trying to execute in real time with the system you're doing. So it doesn't say the canonical is there for a reason. It's there for a reason. So you got this thing here. So you can see here, guys, you got this kind of cube. So this is net of a cube, net of a cube. But this cube is not really a good one. It's basically just you got a self so you can fold it in. So fold this into him, and then fold one, two, three over. So you get four cubes. But this cube is very important. If you fold it, you got a cube. But that's what I'm going to give you now. Now let's do the detonator. So don't think about the detonator and the fuse as different things. Think them as the same property. So if you got it works in the electromagnetic, it works in a magnetic realm, which are called the sound waves, electromagnetic. But in the so if you're thinking about them as in time, you're thinking about them as Coke snowflakes, as some kind of area system. So let's go to here. So what I'm saying here is you got a stack of dominoes, and one domino hits one domino, and one domino hits another domino, and one because the dominoes represent the kind of system that's on the fuse, and the fuse and the until you get the biggest domino fall over. Fall into something and it ignite the system. So the best way you're using it for, but if you donuts falling over, you get like four five dominoes, and one get bigger and bigger. Area, that's what it remains. So you get an area of let's say a two, and you get 4 4, and you get plus 2, so you get 2 plus 4 is 6, and then 6 plus 6 is 6 plus 6 is 10, 10 10, and 10 10 plus 10 so 16 16. So basically, I'm giving you a model of how this works in practical. Because if I don't, my point would be like meaningless. My main point would be meaningless. So if you remember the Fibonacci sequence, that's what we're gonna use here to calculate the error. I don't even know what I'm doing. So we got the Fibonacci sequence. So that would be to the no. I am thinking so basically you start at number one. Let's start with the number one. So this is so if you get the area, so if you get the first one, two, three, or one, starting from the first one with two. 1, 2, 3, 4, 5. So if you go 2 to 13, and they are because you don't start from 1, 2 to 13, let's start again. So you get the area is 2, 3, 3, 5, 5, 8, 8, 13, 13. Then you get 2 times 2 is 4. 2 times 2, 2 squared is 4. So the area is 4. 2 times 2 is 4. 2 times 2 is 4. And that's the area, is 4. And then 3 times 2 is 9. And then 5 times 5 is 25. 8 times 8 is 64. 3 times 13 is what? 8 times 8, 7 times 8 times 8. And 30 times 13 is 169. One is so once you said so the goal of this is to determine if they fall over, there's a force that applies, but it's not physics fault. It's just so what I'm saying the thing is doing is they have some kind of wire. So when you have a plastic cap, that component is a fuse. It's a fuse. It has a fuse, and this is a wire. It's a piece of wire that you can cap. You use to be if you like to detonate on a dynamite system, there's no fuse. There's no fuse. So think about that without fuse. So the detonator without fuse has no fuse, and that no fuse is literally a detonator gonna detonate, gonna explode. It's gonna explode. Seriously, it's gonna detonate. So if you think about that, a detonator is gonna detonate. It gets explode. So what that means is like, and it's no physical. So what does that mean? So you're gonna have a sequence of growth of time. So you're gonna have time. So if you think about if you have time, time is the only thing you have. Then it is let's so you're gonna have the wire keep lights up. It's the time that it will detonate the dynamite on the other end. But that time is mapped to the fuse to do it. But if you can stop it and do which is the sequence of stop sequence and start sequence you have between the fuse and the dynamite at some point in time. So basically, this is it. The fuse is really the dynamite. Doesn't matter if you have your dynamite, if you have a dynamite that's already fused or not. There's some kind of the kind of a way you can stop the fuse with a fuse. You can use kind of fuse on the dynamite electrically. So if you call like red, green, blue red, green, blue, and those wires are causing some kind of you can literally just stop the bomb from because the detonator is basically working on a kind of sequence of timing. So this is like a time graph, a time capsule. So what's the time I'm meant to stop the system fuse based on the length of the code? Just think of what the problem, but it's basically a problem in the mathematical domain for me because it's kind of a big problem for me. Basically, how to stop a time from exploding. How to stop a dynamo from exploding? Because the dynamo is just a red, green, blue. The three wires are basically cut. There's three wires, but you have to select it in time and issue the fuse. And the fuse is a pair of scissors cutting the fuse. So the fuse is not really there to stop. You just use initially it's just a pick a wire to cut based on the power. So basically there's a time limit to that fuse, and that's what it's not because So basically you have a start and stop sequences you can execute as the dynamic goes, and cutting the right time in the right space because the time equals the whole dimension of space you have. But the time is a dimension of space. You go space time continuum, but the space is not ideally. So if you start to diffuse the bomb, you have to cut the wire. There's three wires that normally hooked up, in the dynamite. Unless it's like it's not special. You just have to cut it, and the more cords, the more better. The more cords, the better. So the more the chances you have to diffuse it. So the problem really here, I'm saying, is the fuse is an electricity system. The fuse is an electrical system, and that electrical system is a magnetic one. Has magnetic magnetism. That you can cut the fuse, you can issue the fuse and stop, and just start and stop. So let me just find one more thing before I continue with the Fibonacci sequence. The thing I want to find is the kind of it's a timing kind of a mitigation system. So I want to find a phase buzz. I want to find something called Coke snowflakes presentation. But I want to use this presentation as it's not my presentation. Slide share. So this is slide share. But I'm not gonna use this. I'm just gonna keep making stars. So I don't know. This is a theory. I'm gonna just play. Use this. I'm gonna download it. I'm just gonna just use it as it is. It's embedded. I don't even know. Oh my days. So let's just use. How do I use it? Download for 30 days. Upload. Can I start it? No. I can't. I don't think I can. I don't think it's presentation. But I don't think I can use the presentation. So let me just go to slideshows or the clock stuff with you, and I'm gonna try to use this number here. Slideshare search. I hope I can use this presentation. I hope I can. Can I download free for 30 days? Yeah. I'm not done. So the goal of this presentation is free. Uh, saying factor random in C++, which is geometry, master statistical reports. So, you know, oh, I can download it. I can so I'm just trying to, because I saw that one. I think it was meant to be free. But I'm just gonna upload the presentation. I'm just gonna because I like it because a lot of work there don't do work. So I'm just gonna fine. Sorry guys, once again. So I'm for presentation right now. Uh, free online presentation. Joke still start with them. So this is a coke snowflakes. You know what I'm saying? It's basically a crystal, a crystal. So you can understand, the essential. So, this is more. So the crystal is basically what the space something shares at a time. So we have ice crystals, and we also sand crystals, glass crystals, sand. But, the sand goes through some process of crystallization. So when you get sand, you just go through some crystallization process. Become a crystal before you get to glass, which is transparent and translucent. So how to do it? So I'm saying to you, the doesn't matter what it is, whether something freezes or not, you have to go through some, sorry, let me go through specialization. And the specialization process is the space and time. So this area is mathematically geometrically aligned with the kind of principle of the fuse and the detonator because it's going to be a safe thing, safe first. So, if you don't believe me, a coke surface is literally one type of crystal that you can get if you have four sets of parameters. Four sets of parameters you're saying. It's basically so this is like so what's the problem? So you get a operator start color of the curves. Two, four, five. So this is like too much curve. One, two. Line without borders, color white. I'm not white. So basically, draw a Coke circle with a thick border. Basically, this is example with a thick border. I'm saying, but the Coke circle is basically there's a formula for it. There's a mathematical formula for it. So I'm trying to find the mathematical formula for the kind of slow flick. Because the goal of this is to tell you that it works and it works as intended. Because the Coke slow flick is a mathematical geometry. It's mathematical how to get the area of a cold snowflake. Because you said, and that is what the fuse and the time is operating on. Basically, the area of the space and time overlap, and the overlap is basically in dimension. But I'm trying to use I'm trying to use the coke snowflake to solve this problem. It's basically ontological research. Area and okay, this video should be good enough to do it. So, add, 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 add. I'm busy. I'm busy, mate. Sorry, mate. I'm busy. You know I'm busy, mate. Oh, fucking hell. I'm busy. Come back later. Mm. Yes, yes. Is on the phone? Okay, so I'll be back. I'm coming now. Yeah, I'm coming now. The one second. You go. I'm coming. Thank you. Yeah, thank you. I'm coming. So it is no. So I have a meeting tomorrow. So I'm saying. So it's basically So you can see the parameter is 3, and and the area is pi 3 over squared. Which I don't even know what the p stands for parameter, and area is it's called the surd, the rational number of the surd of 3 divided by 4, because the area, you divide it based on the geometry, but these are called auxiliary constructions that you do in time. So it basically works because you get more area for the more space you have. So you can extend the time by where you cut if you make a mistake. So you don't want to make a mistake. It's basically a Cook-Stokes model. So the area. So this area. So if the area of the perimeter is 2, 3, 5, 8, 16, 13, you will see what I'm saying. Okay, guys, stay here. Go on this video now. I have to go now. I'm coming now. Yes, I'm coming. Is your representative for tomorrow? Yes, I'm coming. I'm just saving my video. I'm just saving my work. 1 second.